inscribed regular polygons, something that's definitely coming up on an assessment. Page 231, please be on page 231. Let's do a little bit of screen cleanup in the moment. Now, for this one, I hope you have some highlighters, something to write with, and maybe a calculator, or maybe just like keep in mind that we're going to be asking you to do some mathematics. Let's get into it. We're going to be talking about inscribed polygons, and that word inscribed came up in our vocab from, let me find it up here, move this out of the way. There we go. Still no. Inscribed angle. That's not even in the view. An inscribed angle is where the angle is completely contained inside the circle. Just a heads up for the future. We're also talking about these things called angle bisectors. And it's like a perpendicular bisector, but advanced. So we need to know how to do perpendicular bisectors and then come across this one. Our learning goals. We're going to use construction tools to duplicate an angle. That's like a this thing, a compass, and like a this thing, an edge that's straight. We're going to construct a regular hexagon inscribed in a circle using a variety of strategies. I mean, I've got a favorite one, but we'll also consider this one. We're going to construct a square inscribed in a circle using patty paper and a compass and a straight edge. I mean, those are the construction tools. We're going to use construction tools to bisect an angle. I'm going to bring in a different highlighter color because that is 100% related to the key term. And then we're going to construct an equilateral triangle using a compass and straight edge. And we're going to construct an equilateral triangle inscribed in a circle. We're going to do all of those learning goals in this lesson 3, page 231. Rewrite each expression. Let's get into the review section. Okay, I'm going to zoom in a little bit, make sure it's visible here, bring my face back. There we go. Okay. And a focus. So in rewriting each expression, what we're looking for is things that we find in common. So like we have x squared plus x squared. If it helps, this is the visual. I have a square, and the sides of the square are x, so that the inside area is x squared. In fact, I'm going to add to that another one. X squared is the inside box. The edges are x and x again, but there are 2 of them. And because there are 2 of them, we can simplify or rewrite this expression to be 2. There they are, of these x squareds. Sorry, this screen looks like a PowerPoint right now. Okay, let's go to number 2. In number 2, we have the square root of 3, and then it's squared. So with the same analogy as part 1, that means that we have inside here square root 3 squared. That means on the edges are square root 3 and square root 3. If you multiply something by itself, you end up creating like a squared, and a square and a square root will actually cancel out. So this becomes just a box with 3 on the inside because square root and square cancel. Cancel is the word. There's in the screen for you. Let's go to number 3. In number 3, we're kind of combining both of them. And so a rule of exponents, or a rule of combining, says we're going to put square root 3x on the edges of this box. And it has to stop. Do not put the x under the square root right there. So I put that little hanging tail just to be like, whoa, stop, it's over. Now, when you multiply both of these together, we would do square root 3 times square root 3. That's the result from question 2. Square root 3 times square root 3. Those 2 multiplied together is just like this box. And that would mean that they cancel, they create a 3. Then we consider the x. Ooh, highlight time. Highlight, boom, boom, boom. Then we consider the x. And so x times x is just like that example where you have x on the outside of the box. When you multiply them together, you get x squared. 3x squared is what you get from rewriting this expression, 3x squared. So building up all of these pieces, now we can tackle question 4. And in tackling question 4, this has already been answered with number 3. So I know that I can rewrite square root of 3 times x. When that product is squared, the result is 3x squared. And it happens a second time. So there's another square root of 3 times x. That product is squared. But there's two of them. Just like in number 1, where there was 1 and there was 1x squared, and then we added another x squared that created 2x squared. Here we have simplified and simplified 3x squared plus 3x squared. 3 plus 3. 6x squared. Pay special attention. The 2, and the 2, because we're adding, stays a 2. You might think it should be a different number. I don't want to project what number you might think it should be because that's not right. The 2 plus and then the squared. The squared and then plus this term with a squared, it should stay a squared. Only when you multiply do you get a higher exponent. Thanks for watching page 231. Stick around for what's next. More lesson 3 to follow. Thanks. Bye.